for coming. So I have the pleasure to give you a short presentation about what we have done in the last months and development in terms of release agent. I will give a talk about optimized mold release agents for new structural components made from naturally hard alloys. A few words about our company. Our company called Geiger, Schmierstoff-Chemie, has been founded now 110 years ago in Heilbronn in Germany. We started as a retailer of oils and lubricants, and since about the 1960s, now for around 60 years, we are specialized in release agents for die casting. Production, development, administration, all is in Germany, in Heilbronn, which is close to Stuttgart in the southwest. And yes, we have approximately 30 employees. What we are doing is, under the brand name Trennmittel, we are developing, producing release agents for all kinds of high-pressure die casting for aluminum, magnesium, zinc, and brass. Also the plunger lubricants. We also have die coatings for low pressure and gravity casting under the brand name Microcollet, and also some forging lubricants under the brand name Ferrobrass. Today I want to focus on structural die casting, and development in the last years that we've seen in automotive die casting is that, yes, the machine size got bigger and bigger. When 10 years ago I was for the first time on EUROGUSS, I think it was common that the biggest die casting machines were around 4,000 tons. Now, 10 years later, I have to change this slide every time when I make this presentation. At first I set the upper limit at 9,000 tons, then at 12,000, and now I think in November we got news that even a 16,000 tons machine will be soon available. At the same time also the structural castings have developed. 10 years ago a front jack tower or a longitudinal beam have been large structural castings. Now we have battery cases, and now even whole underbodies, front underbodies, rear underbodies. So this is really interesting what has happened in the last years. With structural die castings, you can choose in principle between alloys that are hardenable by heat treatment or self-hardening alloys. Normally, if you have a traditional hardenable alloy, then a normal heat treatment procedure is maybe like a T6. You start with a solution annealing where you keep the casting for several hours between 460 and 550 degrees centigrade. Then you have a quenching step, and after that maybe another step called artificial aging, several hours between 150 and 240 degrees Celsius. If you choose a naturally hard or a self-hardening alloy, that means you do not have these steps before. You can use the casting really as cast, or you have a natural aging at room temperature. This is a self-hardening alloy. This means you save a lot of money, costs, and also carbon dioxide, because you do not have these energy-intense steps before. So here is shortly some pros and cons of this heat treatment, especially the solution annealing, which is the most energy demanding step. Yes, heat treatment has a high energy demand. It is a process that takes time, it has a long process time, and now there are also two technical aspects. Heat treatment leads to a distortion of the castings, especially during the quenching step. This means you have another step called straightening of the castings in order to correct this distortion that can happen. And with a very big casting such as a rear underbody, it's nearly impossible really to make the straightening. So this is really one point why you can say technically it's very difficult to make heat treatment with these really big castings. Another point is also the blister formation. You have to be sure that you're using a very good vacuum in order to get rid of all the blisters that could form when you make this solution annealing. Pros of this heat treatment, and that's the reason why it's still done, is you have very well-defined mechanical properties, you have a very secure process that is well established, and now, and this is the point where I want to address today, all residues that we have on the castings when we take it off the die like release agents or other oils that are removed during this heat treatment process. We have tested this in our labs by a thermal gravimetric analysis, and we have just kept some release agent residues at 460 degrees centigrade, and you see within minutes, even here we see the weight loss or the mass loss, and here we see the time, and already during preheating and when we have reached the temperature, within minutes we lose all release agent residues during this annealing step. When we do not make solution annealing, so it means maybe we only make artificial aging at a much lower temperature, for example here 240 degrees Celsius, yeah, we do not have this weight loss. It's much less, and even after 30 minutes we still have 80% of the original, this is only an example, 80% of the original residues on the casting. And you can imagine if we omit all types of heat treatment, we are still here. So we do not remove all our residues. That means in order to clean the castings without heat treatment, we have to find a way to get rid of these residues. And shot blasting, vibro finishing is, with these big components, is nearly impossible. I cannot imagine how to make it because the castings are just too big and they will be distorted during these processes. So what we have to do, the only way to get rid of the residues is washing. And so it's very important to choose an appropriate cleaner for this step. Because what happens when we do not remove all residues from our castings, there are several problems. We will have problems with joining processes, such as welding or gluing, because it won't work, and this will also bring some safety issues. On the other hand, when we want to coat these castings, because they normally need a coating in order to have corrosion resistance, especially the electrophoretic coating is very important for the structural castings. They will have problems, and very often we see that with castings that have not been cleaned appropriately, you will fail through the corrosion test, for example. So it's very important to get rid of the residues, and so in order to look for an appropriate cleaner, we have to look at the ingredients of a release agent. So what's in a release agent? Roughly said, yeah, we have mineral oils, vegetable oils, some synthetic oils, and then we have mostly waxes and polysiloxanes. We only use paintable polysiloxanes, but these two ingredients are very important for providing the temperature stability of the release agent and also for providing the lubricating effect. Now we have roughly evaluated all these ingredients in terms of their washability, and this is a very rough overview how we can remove these ingredients. And yeah, mineral oils, vegetable oils, most synthetic oils are quite easily washed down by, you can use solvents or neutral aqueous cleaners or alkaline cleaners. Normally you do not need elevated temperatures. However, with polysiloxanes, it can become a little bit more difficult. So here, with an appropriate alkaline cleaner, normally it's no problem. Yep, I'm sorry. With waxes, sometimes we see the most problems. You can distinguish between polar waxes and non-polar waxes, and waxes need elevated temperatures because this really promotes a faster cleaning of the casting, and especially with non-polar waxes, it could really be that the casting is more or less impregnated by the wax, and sometimes very hard to remove the residues. So when we go, now it's not working. Yeah, now it's working. If we choose an appropriate release agent for structural casting, traditionally we could choose between high wax, low wax, or wax-free and polysiloxane-free release agent. But then you say you have a release agent, or you have a structural casting without heat treatment, I would say we would not longer recommend a high wax release agent, either wax-free, low wax, or polysiloxane-free release agent. Because, so what do we mean with a polysiloxane-free release agent? These are release agents that are based on a blend of waxes and oils, but no polysiloxane. This means it's excellent in terms of washability of the castings. We have immediately a high surface energy of the castings. So we see it quite often when we take off the casting directly after the shot. We make something like a water break test. We just pour water on the surface, on top of the casting. You see immediately in terms of the droplet formation that these castings have a high surface energy and they are very well coatable. For example, we have here our product is Trennix CI7. It's one of the earliest developments in these terms of release agents for structural castings. This has even got an OEM approval, especially also for structural cuts without treatment, but that are subsequently also bonded structurally with a glue. But here in this case also we have a problem with this polysiloxane-free release agent because the thermal stability is limited. That's the reason why we have also developed a lot of polysiloxane-based release agents which are wax-free or have a low wax formulation. And for this we have chosen some novel paintable polysiloxanes and special additives which both make no problems with the washability and paintability. So we have virtually no residues on the castings, we have very bright castings, we have an excellent release effect and an excellent temperature stability, especially for these big castings. This is very important, and they are easily washable with suitable cleaners. And here we have done a lot of new developments for gigacasting. I can give you a rough overview of what we have developed in the last months. Again, it's not reacting yet. Now it's reacting. Yes, that's the slide. Yes, for standard spraying we have, for example, with polysiloxane-based, our Trennix 3351 series, which is very successful in terms of structural castings without heat treatment. The polysiloxane-free product I mentioned before, and then also for minimum quantity spraying we have water-based developments like the 060 series and also polysiloxane-free developments like the 79 series. Also, customers asked for release agents without water, because why without water? Yes, the pure oils have some advantages. They bring no cooling into the dye. This means we have no cold running of the castings and no water in the mold, because you can imagine these huge structural castings, they often have the problem that the dye temperatures are in some areas much lower than expected. So these are optimized in terms of washability. You can apply them electrostatically, so we can modify them in order to make them applicable electrostatically, and for well-tempered molds where you don't have temperature problems with too high temperatures, we could say they are well suitable. And here we have, for example, polysiloxane-based products and also polysiloxane-free products, which are also quite successful for these structural castings. As to plunger lubricants, we've often been asked what's possible with plunger lubricants, what should I choose? The problem is for plunger lubricant we have a high amount of liquid aluminum between 100 or 150 kilograms per shot, which is poured into the sleeve. And you could imagine here in this area where we pour it in, we have an area where we have possibly heavy damage by leaching. And it's a large amount, and it's alloys with a low content of iron. This means that they are very aggressive towards the steel. And so these are two challenges, and to our experience, the solution for these problems is, on one hand, we use graphite-based plunger oils. They are very successful because they are very effective. The graphite will build a protective layer, especially in this area, and will protect the sleeve from the liquid aluminum. And on the other hand, water-based plunger lubricants containing waxes will also form a protective layer in this area, and some customers even report of a combination of both. They are using as well the graphite-based plunger oil and the water-based plunger lubricant in order to protect their sleeve. So after this, I'd like to show you some case studies, some examples, what is possible with our release agent. This is from one customer in Asia. It's a rear underbody for electric car. It's been cast on a 6,100 tons machine in Asia. This casting will be welded. These are two halves of one underbody, so these will be welded here. Then it will be coated electrophoretically by an e-coating. And the whole casting, the whole alloy is, of course, without heat treatment. And this has been cast by our Trenix 3351. And also the plunger lubricant is our graphite-based oil 3099. Another example on a 9,000 tons machine. Here the rear and the front underbody for an electric car is also cast with our wax-free release agent, also electrophoretic coating without heat treatment. I could show you some more examples, but I think the best way is just to invite you to our booth. Here. We are very happy to have got one casting from one of our customers from China as a part example, and you can find this on our booth in Hall 7, booth number 7114. Again, a rare underbody on a 9,000 tons machine cast with our product. As to Asia or the Gigacasting market in China, we have made in November last year a short survey what's the status quo of the large die casting machines. Yes, and we have seen that there are total at the moment, or in November, there were total around 44 die casting machines. 12 of them have been in installation or doing assembly, but already 32 were in serious production. And we could say of these 32 giga presses or mega presses or large die casting machines in China, around 21 are currently running with a Trenix release agent. So we are quite proud of this. So now it's a little bit smaller. So on the last sheet, I would say as a summary that of course the increased energy costs and the new component dimension require an increasing use of alloys without treatment in structural casting. This means that the omission of heat treatment can have a strong impact of subsequent processes such as coating and joining. So I would say for the successful implementation of new projects, all those that are involved along the process chain from foundry up to the coating and corrosion department, they should be involved at the beginning because it really matters all departments on the way of the casting. And our summary is that in most cases, wax-free or low-wax but polysiloxane-based release agent, they offer the best compromise between castability and coatability. So I'm at the end of my talk. I thank you for your attention, and I'm open for your question. Thank you.